In today's world, lightweight yet strong components are crucial in automotive industries. This is where tube hydroforming plays a significant role. Tubular components offer enhanced strength, lightweight, and design flexibility. So from chassis to exhaust systems, roll cages to suspension components, tubes are the backbone of modern vehicles, providing structural integrity while optimizing performance. Hello everyone, I am Mayank Gupta, the product manager with AutoForm, and through this video, let's explore with me this cutting-edge technology of tube hydroforming, which is revolutionizing the automobile industry. Compared to traditional sheet metal components, tubular parts offer a plethora of advantages. Firstly, their superior strength to weight ratio improves fuel efficiency and overall vehicle performance. Furthermore, their inherent stiffness enhances crashworthiness, ensuring passenger safety. While tube hydroforming offers numerous benefits, it also presents its fair share of challenges. One of the primary concerns is the process complexity, because of which finding out the optimum process design and parameters can be quite challenging sometimes. Fortunately, advancements in digital simulations have revolutionized tube hydroforming, mitigating many of its inherent challenges. Through sophisticated softwares, engineers can accurately predict material behavior, optimize tooling design, and simulate the entire forming process virtually. This not only reduces development time and cost, but also ensures the production of high-quality components with precision and reliability. Two approaches commonly employed for process optimization during engineering are traditional hit and trial method and the systematic process improvement approach. So let's explore the benefits of the systematic process improvement approach over its traditional counterpart. The traditional hit and trial approach involves making changes to the design and manufacturing process based on intuition or past experience. It often entails a trial and error method where adjustments are made without a clear understanding of the underlying causes or potential outcomes. While this approach may yield some improvements, it is inherently inefficient and can lead to prolonged downtime, wasted resources, and inconsistent results. In contrast, the systematic process improvement approach follows a structured methodology to identify, analyze, and address process inefficiencies systematically. In one of our webinars, through a case study, we demonstrated in detail one such systematic approach to optimize the tube hydroforming process, wherein we optimized several process parameters like tool design, tube thickness, axial feeding system, fluid pressure, and tube diameter through a smart and systematic approach. With this smart approach, we could not only identify the issues, but we could also find the solution with the clear identification of the process windows within which the issues can be resolved. So let's consider two process parameters, fluid pressure and axial tool displacement. A high fluid pressure can result in splits, and a large axial displacement of tools can result in wrinkles. So finding the right balance between these two parameters is critical. And with the demonstrated approach, we could find a clear process window for these two parameters, which would result in the tube forming without any splits or wrinkles. So in conclusion, while the traditional hit and trial approach may offer quick fixes, it pales in comparison to the systematic process improvement approach regarding efficiency, effectiveness, and sustainability. So by embracing a structured methodology and fostering a culture of continuous improvement, organizations can unlock their full potential and thrive in today's dynamic business environment. If you are interested in more details, please check out the recording of the webinar through the link provided in the description. And if you have any questions, please feel free to reach out to me through LinkedIn. Thank you.